Something really strange is happening right now way out in our solar system. Neptune is completely different from what we thought. The outermost planet in the solar system has only been visited up close once so far. And yet, it's currently leaving scientists speechless. From shrinking storms to icy doppelgangers to rings we've never seen in such sharp detail. Stick around until the end, because what's just been discovered on the blue giant is gonna blow your minds, folks. Today we're talking about a planet that usually gets very little attention, Neptune. And if you're just as fascinated by these mysteries from the depths of our solar system as I am, feel free to subscribe to the channel right away. It doesn't cost a thing, and you'll always get a notification when something new comes out. And if you're already subscribed, you can really help this video by giving it a thumbs up. 5,000. At the edge of our solar system, where the sun's light falls through the darkness of space as nothing more than a distant glow, a massive planet follows its solitary orbit. And yet it is a fascinating part of our cosmic neighborhood. A blue giant with an eventful history and many unsolved mysteries, its name is Neptune. Neptune is the 8th and outermost planet in our solar system, unless you count Pluto, which was officially reclassified as a dwarf planet in 2006. It is located at an average distance of nearly 4.5 billion kilometers from the sun, a place beyond the so-called frost line, where ice and gases were able to condense into massive celestial zones and bodies. So far out that a beam of light from the sun takes over 4 hours to reach Neptune. A year on this blue gas giant lasts 165 Earth years. Neptune was the first planet to be discovered not through optical methods, but through pure mathematics. In the early 19th century, astronomers noticed that the planet Uranus was behaving strangely in certain respects along its orbit. Its position in the sky deviated minimally but measurably from the calculated values. Two scientists, John Couch Adams in England and Urbain Le Verrier in France, independently suspected that a previously unknown celestial body must be influencing Uranus with its gravitational pull. Le Verrier sent his calculations to the Berlin Observatory, and there, on September 23, 1846, the German astronomer Johann Gottfried Galle pointed his telescope at the calculated position, and then he saw it. A small bluish point of light in the sky, but unmistakably a planet, a scientific sensation, a planet predicted by mathematics. Yet despite this promising discovery, Neptune remained a distant mystery for a long time. The telescopes of the 19th and early 20th centuries revealed little more than a smooth, featureless sphere. That didn't change until 143 years later. In the summer of 1989, NASA's Voyager 2 probe flew past Neptune, a final bonus stop on its journey through the outer solar system. It was a flyby with only a few hours of close contact, but those hours were enough to fundamentally change our image of Neptune. The probe transmitted detailed images of a deep blue world crisscrossed by massive storm systems, white methane clouds, and the so-called Great Dark Spot, a gigantic cyclone as large as Earth, which later disappeared, however, and can no longer be found today. Neptune's atmosphere consists mainly of hydrogen, helium, and methane. The latter is responsible for its distinctive blue color. But what really makes Neptune special is its weather activity. The fastest storms in the entire solar system rage here, with wind speeds of up to 2,100 kilometers per hour. How is this possible so far from the sun, with so little external energy input? Presumably, the planet's internal heat plays a role. Neptune radiates more than twice as much energy as it receives from the sun. This points to a hot, active core. Its magnetosphere also poses a mystery. Neptune's magnetic field is strong but strangely tilted. It is tilted about 47 degrees relative to the axis of rotation and is also significantly offset from the planet's center. This is a phenomenon we have not yet observed in this form on any other planet. Its moons are also unusual, such as Triton. It moves in a retrograde orbit, that is, in the opposite direction of the planet's rotation. This is a sure sign that it did not form with the planet but was captured later. Triton is also geologically active. There is evidence of cryovolcanism, icy geysers that hurl frozen material from the interior into space. No space probe has examined Neptune up close since Voyager 2. The last true planet in our solar system remains largely uncharted territory to this day. A modern mission there would require decades of planning, a budget in the billions, and a great deal of patience. And yet, the scientific treasures waiting out there could be groundbreaking. Neptune is not just a planet, it is an archive of the early solar system. Those who understand Neptune may also better understand other planetary systems and thus our own. This is how our journey begins today. Neptune is too distant, too extreme, too mysterious for us, and yet, or perhaps precisely because of that, it is a fascinating example of the immense forces that are still at work even at the icy edges of our solar system. Neptune belongs to the class of so-called ice giants along with its neighbor Uranus. This distinguishes it from Jupiter and Saturn, which are considered ordinary gas giants. While Jupiter and Saturn consist largely of hydrogen and helium, Neptune contains significantly higher proportions of heavier elements, particularly water, ammonia, and methane. These substances are mostly frozen at the low temperatures far out in the solar system, hence the term ice giants. But of course, Neptune is not a lump of ice. The temperatures and pressures inside are so high that exotic states form there, unlike anything we know on Earth. Neptune's atmosphere is a raging ocean of gas, dominated by hydrogen, helium, and about 2% methane. But the real fascination begins beneath the surface in the dynamics of the atmosphere. For although Neptune is so far from the Sun and receives only a fraction of its heat, it is anything but calm. On the contrary, Neptune has the most extreme weather dynamics in the entire solar system. Winds rage there at the speeds of up to 2,100 kilometers per hour, faster than the speed of sound within Earth's atmosphere. The atmosphere rotates in massive walls around the planet, similar to Jupiter, but at a significantly higher speed and with much stronger turbulence. In 1989, the Voyager 2 spacecraft discovered the so-called Great Dark Spot, a gigantic storm system similar to Jupiter's Great Red Spot, only darker and faster. It was about the size of Earth and swept across the planet within a few days. But when the Hubble Space Telescope looked again a few years later, the spot had disappeared. A few years after that, a new storm formed in a different location. Neptune's weather is not only powerful, it is dynamic, unpredictable, and constantly changing. Neptune receives only about 1,000th of the solar radiation that reaches Earth. Nevertheless, the planet emits more than twice as much energy as it absorbs. This excess heat likely originates from within the planet, either from residual heat left over from its formation, or from slow convection processes in its interior. No one knows for sure yet. Beneath the turbulent atmosphere lies the so-called mantle, a vast layer of hot, dense ice composed of water, ammonia, and methane, in an exotic state that lies somewhere between liquid and gas. Scientists suspect that this mantle might even contain a special form of water, superionic ice. In this state, hydrogen ions move freely through a lattice of oxygen atoms, a kind of electrical conductor under enormous pressure and at extreme temperatures. This layer could be crucial to the unusual shape of the magnetic field. It is extremely strong, but heavily tilted, about 47 degrees to the axis of rotation, and moreover, it is not symmetrical, but offset from the planet's center, a chaotic magnetic field that differs greatly from the fields of other planets. The cause of this likely lies in that very electrically conductive layer deep inside. The planet's core, if it even exists in a clearly definable form, probably consists of rock and metal. However, due to the immense pressure at a depth of over 10,000 kilometers, even the hardest material there is likely to exist only in an extremely compressed state. We're talking about pressures millions of times higher than those on Earth's surface. In recent years, astronomers have discovered thousands of so-called exoplanets, many of which have sizes and masses similar to those of Uranus or Neptune. These classes of planets, larger than Earth but smaller than Jupiter, appear to be extraordinarily common in the universe. Neptune is therefore not a special case, but a cosmic archetype. If we want to know how these ice giants function in the vastness of the galaxy, then we must understand Neptune, a place where matter exists in forms that we on Earth can only imagine in particle accelerators or simulations. While telescopes like Hubble or the James Webb Space Telescope provide new insights, a real visit is still missing. The blue giant thus remains one of the biggest unresolved chapters in the book of our solar system. A planet is more than just a single celestial body, it is a system. And when it comes to Neptune, it's worth taking a closer look at what surrounds it, its moons, and a little-known phenomenon, its rings. Because Neptune is not alone. As of now, it has 16 known moons, and at the head of this family is a fascinating enigmatic object, Triton. Triton is Neptune's largest moon and accounts for over 99% of the system's total lunar mass. But it's not just its size that makes it extraordinary, it's its origin, its orbit, and its internal dynamics that make it one of the most fascinating objects in the entire solar system. It orbits its planet retrograde, meaning in the opposite direction of Neptune's rotation. A retrograde, slightly inclined orbit is strong evidence that Triton did not form alongside Neptune, but was captured later. It is believed that it was once an independent celestial body in the Kuiper Belt, the zone of icy objects beyond the planets. Triton is also very active. During its flyby in 1989, Voyager 2 discovered geysers of frozen nitrogen shooting several kilometers high into the atmosphere. This is a clear sign of cryovolcanism, geological activity involving frozen materials rather than hot magma. This is astonishing, especially since Triton is so far from the Sun. Its surface is bitterly cold, around minus 235 degrees Celsius, and yet something is happening deep inside. Possibly due to tidal forces, that is, gravitational stresses caused by its slightly elliptical orbit, or due to the slow decay of radioactive elements deep inside, or both. There are even theories that beneath Triton's icy crust there could be an underground ocean of liquid water, similar to those on the moon's Europa or Enceladus. If that's true, Triton would not only be a geological marvel, but also a potential candidate for extraterrestrial life. In addition to Triton, Neptune has a whole host of smaller moons. Many of them are little more than captured chunks of rock. Take Nereid, for example, one of the most remote moons in the solar system with an extremely eccentric orbit. Or Proteus, Neptune's second largest moon, an irregular boulder barely round, pockmarked with craters. And then there are tiny moons like Despina, Galatea, Larissa, and Naiad. Many of them orbit close above Neptune's clouds and are likely remnants of past collisions or shattered moons. This inner region is not only full of moons, it is also crisscrossed by a ring system that is often overlooked. For Neptune, much like Saturn, has rings. However, they are much fainter, much darker, and harder to detect. It was not until Voyager 2 that definitive proof was provided. Neptune's rings consist mainly of dark dust and rock. Presumably, they are made of material released during collisions between moons. There are 5 main rings, the best known of which are called the Adams Ring and the Le Verrier Ring, named after the 2 astronomers who independently predicted Neptune's existence. A particularly curious feature is the ring clumps, lumpy concentrations in the Adams Ring that look like glowing knots. They are called arcs. Why these arcs persist rather than dispersing evenly is not yet fully understood. It's possible that small moons like Galatea stabilize these structures through their gravity, a kind of cosmic resonance. Overall, Neptune's rings appear much younger and more unstable than Saturn's. It's believed that they aren't very old, perhaps only a few million years. If that's true, we are witnessing today the transitional state of a slowly disintegrating ring system that could eventually dissolve or transform into new moons. And that is precisely where the beauty of Neptune's family lies. It is dynamic, unstable, and in a state of flux, a mini-cosmos of moons, dust, and gravity that grants us deep insight into the chaotic processes of the solar system. And all of this is taking place in a region we've only visited for a few hours so far. NASA and ESA have been discussing a return to the Neptune system for some time now, with probes such as the planned Triton mission, which could study Triton in detail, because if there's life out there somewhere, it might be exactly where we least expect it. Not in the sunlight, but beneath a shell of ice. Since Voyager 2's flyby in 1989, things have gone quiet around Neptune. The last chapter in active Neptune research took place over 3 decades ago, an eternity in space exploration. And yet the desire to return there is greater than ever. That's because Neptune left us with more questions than answers last time. The good news is that scientists are working on a return mission. Several concepts are in the planning stages, some are ambitious visions, while others are already on the verge of becoming reality. 3 of these missions are particularly exciting because they pursue different goals but complement each other wonderfully: Trident, Neptune Odyssey, and the Triton Hopper. Let's start with Trident, a NASA mission proposed as part of the Discovery program. Trident is, if you will, the most pragmatic plan. A streamlined space probe, no orbiter, no landing, but a targeted flyby of Neptune's moon Triton equipped with a high-resolution camera, a magnetometer, and other scientific instruments. The focus is clearly on this unique moon. Triton is a strong candidate for extraterrestrial life, provided there is an ocean beneath its icy crust that derives energy from chemical reactions. Triton could determine exactly that. However, with a flight time of about 13 years, this probe would not arrive until the 2030s or even the 2040s, depending on the launch date. The flyby of Triton is planned to take place at an altitude of only about 1,000 kilometers, closer than Voyager 2, and using state-of-the-art camera technology. The goal is to map the surface, study geysers, analyze the magnetic field, and if possible, find evidence of an ocean. While Triton would be a targeted, brief visit, the Neptune Odyssey concept goes much further. This is a major mission, an orbiter designed to accompany Neptune for many years. Planned and designed by the Applied Physics Laboratory in the US, Odyssey is one of the most ambitious missions ever conceived for the outer planets. The goal is to study Neptune in its entirety, including its rings, atmosphere, magnetic field, and moons up close and over many years. Odyssey is not only intended to serve as an orbiter, but will also carry an atmospheric probe that will dive into Neptune's dense, stormy gas layers. This probe would, for the first time, provide direct data from the atmosphere of an ice giant, including information on temperature, pressure, composition, and chemical processes. Such a mission could also finally shed light on Neptune's ring-shaped dust bands, its strange magnetic properties, and its internal heat source. In addition, detailed observations of all its moons would be possible, including many that so far appear as little more than points of light in the Voyager data. The concept calls for a launch between 2030 and 2035, with arrival in the 2050s. Such a journey is long, expensive, and technically extremely challenging, but it would be the scientific crowning achievement for the exploration of the outer planets. And then there's another concept that sounds almost like science fiction. The Triton hopper. This is a mobile lander that doesn't stay in one place but moves by hopping. That's right. The hopper would hop from place to place multiple times to explore different regions of Triton's surface. The hopper would use nitrogen ice from Triton's surface as fuel. Heating this ice would create a jet of gas that would catapult the hopper into the air. This would allow it to hop across Triton several dozen times, covering comparatively long distances. The concept was explored in the second phase of development as part of NASA's NIAC program. It is technically ambitious but theoretically feasible. And it would make it possible to investigate not just a single point, but entire landscapes on Triton, including cryogeysers, trenches, and icy plains. The Triton hopper is still in the very early stages of development, but it demonstrates just how much creative potential lies in the exploration of this distant world. Fortunately, we no longer have to wait for space probes to discover new details, because a certain space telescope has also recently turned its gaze toward the ice giant. We're talking, of course, about the James Webb Telescope, which with its infrared eyes has captured something we've never seen before: Neptune's rings. It wasn't until the 1980s that the team led by astrophysicist Edward Guinan discovered the ring system by observing stellar dimming and occultations. A sudden flickering of a star just before or after Neptune passed in front of it was a clue to the presence of a ring, since the dust particles in the ring briefly dimmed the star's light. About 50 such dimming events were observed, but only 5 of them truly pointed to the existence of rings. James Webb is now giving us the most detailed look yet into the world of Neptune's rings, a view we've never seen before. Thanks to James Webb's fantastic infrared eyes, we're getting the clearest images of Neptune in 30 years. In the images from the James Webb Space Telescope, we see the planet Neptune with its ring system. We see bands of clouds, methane ice clouds, and a total of 7 of its 14 moons. Okay, some of you might be thinking, what's so clear about that? It looks totally blurry and boring. Here's a quick explanation. James Webb captures these images in the near-infrared spectrum using the near-infrared camera, NIRCam. Because James Webb observes space in the infrared spectrum, the telescope can see much farther and much more clearly. It can essentially cut right through dust and gas. Although we get clearer images of the objects with NIRCam, there's always a bit of a trade-off. As a result, Neptune doesn't appear as beautifully blue to the James Webb Telescope as it would if, say, Hubble were photographing the planet. And because of the infrared spectrum, Neptune actually looks a bit dull, and the planet is visible only in shades of gray. If James Webb could photograph Neptune in visible light, it would shine in a fantastic blue. Neptune's rings consist of dust, rocks, and ice. The rings are very clearly visible in this image, as not only the large rings, but also the finer ones can be made out. In addition to the rings, we can also see Neptune's fascinating moons in the new photo. James Webb has photographed a total of 7 of the 14 moons. Triton is Neptune's largest moon and shines in the upper part of the image. Also clearly visible is a thin band winding around the equator. Researchers refer to this as a global atmospheric circulation system that influences movements in the atmosphere. I don't know about you, but I find this image from the James Webb Space Telescope absolutely breathtaking once again, and I really can't get enough of photos like this. Above all, I find photos like these incredibly important, because they remind us that we don't have to venture all the way out into the universe. There are simply still so many mysteries in our solar system waiting to be discovered. Let's take a quick look at the current state of research, because Neptune is causing quite a bit of confusion among scientists right now. Summer should actually be in full swing in the planet's southern hemisphere right now, so it should be warmer there. Instead, researchers are recording a massive, unexplained drop in temperature on the farthest planet in the solar system. It's getting colder and colder on Neptune. Now, some of you might say 4.5 billion kilometers from the sun, of course it's cold there, dude. That's true, but Neptune has seasons too. Each one lasts about 40 Earth Earth years because it takes Neptune 165 Earth years to complete one orbit around the Sun. 40 years of summer, that sounds really great, even if summer on Neptune doesn't offer quite such pleasant temperatures, namely about -200 degrees Celsius. A new study, which compiled 17 years of observations of Neptune's temperature, shows that there is a mysterious, globally average decline of about 8 degrees Celsius between 2003 and 2018, as evidenced by a significant decrease in Neptune's atmospheric radiation beginning in 2003. How was it even possible to discover this when no space probe has visited Neptune in 30 years? This is possible thanks to powerful ground-based telescopes such as the VLT, Imager, and Spectrometer for Mid-Infrared Telescope, or Visier telescope for short, which is installed at the Very Large Telescope of the European Southern Observatory in Chile and can determine a celestial body's temperature based on its infrared emissions. The research team led by Michael Roman analyzed the data that the Visier telescope had collected over the years, as well as additional results from NASA's Spitzer Space Telescope. The result was the most detailed study of temperature measurements on Neptune ever conducted. However, the question remains as to how the drop in temperature in the middle of summer can be explained. No one knows for sure, but it likely has something to do with processes in Neptune's atmosphere. When the amount of photochemical hydrocarbons changes, more infrared radiation is emitted and the planet cools. Similar processes had already been observed on Saturn. There, it was found that the interaction of chemicals in clouds within the atmosphere can influence their temperature. So on Neptune, there appear to be chemical processes that are so massive that they affect the temperature of the entire planet. One idea is that it has something to do with the giant storms on Neptune. The Great Dark Spot was in fact just one of many storms on Neptune. It has been gone since 1994, but new storms of unimaginable proportions are constantly forming. The formation of these storms on Neptune remains a complete mystery and is barely understood. It could be that they disrupt the chemical reactions in the atmosphere, which might even lead to cooling during the summer. However, the research team at the University of Leicester has another idea. Solar radiation might also be worth considering. This is because the sun goes through multi-year activity cycles, sometimes being less active and sometimes more. The changes in radiation caused by the sun's activity cycle could, in some as yet unexplained way, trigger photochemical changes in Neptune's atmosphere, which in turn could explain the observed temperature fluctuations. But these are all just hypotheses. For now, the atmospheric processes on Neptune remain a great mystery to us, and it gets even more confusing. Since 2018, the cooling trend on Neptune has reversed and it's suddenly getting warmer again. The temperature rebounded within just a few years and has risen by an average of 11 degrees. So Neptune is truly going through a roller coaster of temperature changes right now. All of this points to a complex picture of Neptune's atmosphere and how it changes over time. I think Neptune is so fascinating because we still know so little about it. So, I hope you've now gotten an exciting overview of just how many mysteries the outermost planet in our solar system still holds for us. Of course, I'll keep you updated here on the channel about all future discoveries related to Neptune and the rest of the solar system. So if you haven't subscribed yet, be sure to do so now, and don't forget to hit that thumbs up so we can break the 5,000 like mark. And now let's head back to Earth. At the Wendelstein fusion reactor in Germany, researchers have set a world record that brings us a good deal closer to the energy of the future. To find out exactly what happened there, why it's so significant, and why Germany is a leader in nuclear fusion, check out the video in the top right corner. Be sure to click on it, it's very exciting, and if you want the galactic Astro-Tim shirts from my videos, plush planets, and much more, stop by the space shop in the bottom left corner. Every order really helps support my work. Otherwise, I'd say see you in the next video. Take care, everyone.